Namaste children. Till now we have learned about what is force, how can you apply force, what a force can do, the two kinds of forces, that is contact forces and non-contact forces, the property of the objects, that is inertia, the types of inertia, that is inertia of rest, inertia of motion and inertia of direction, and Newton's first law of motion. What does Newton's first law states? Newton's first law of motion states that whenever a body is at rest, it continues to be at rest, and if it is in uniform motion, continues to be in uniform motion until and unless compelled by an external force. That means, in simple words, Newton's first law defines force. That is, it changes the property of inertia of bodies. How it is changing? By applying external force. Now, coming to Newton's second law of motion. What is Newton's second law of motion? Before going to that, we need to learn what is momentum. What is momentum? For example, you take two balls. One is A with mass m1 and the other one is B with mass m2. So, there is a difference in the mass of the two balls. Think that or assume that mass of the ball A is greater than mass of the ball B. When they both are moving with the same velocity, you need high force to stop the ball A. Why this is? Because its mass is more. So, force is here, applied force is directly proportional to the mass of the body. Now, consider the both balls will have same mass, let it be m, but they are moving with different velocities. One is moving with high velocity, that is the velocity of the ball A, let it be more than the velocity of the ball B. Then force applied to stop ball A is greater than the force applied to stop ball B. That means force is directly proportional to the velocity. Now, coming to the definition of momentum. Momentum, according to the physics, nothing but the quantity of motion present in a body. The quantity of motion, how it can be measured mathematically. Mathematically, momentum is nothing but the product of mass and velocity. So, what example we have seen? Two balls, one is A, the other one is B. First, what we observed, ball A, we have considered mass as m1, ball B, we considered its mass m2. Now, we discussed that m1 is greater than m2. So, force applied to stop ball A will be greater than ball B. So, force is directly proportional to mass in this case. This first we have discussed. Now, coming to the second example. Now, the velocities are different. Mass of ball A and B are, let it be m only, but the velocities are different. Let A is moving with v1 velocity which is greater than the velocity of b ball which is v2. So velocity v2 is less than v1. So v1 is greater than v2. Then the force applied to stop ball A will also be greater. That means force is also directly proportional to velocity of the balls. This is second one. Now, according to the physics, what is momentum? Momentum is designated by capital P and it is nothing but the quantity of motion possessed. Newton's first law of motion states that if a body is continues to be at rest and or of uniform motion, it continues to be at rest and uniform motion only until and unless compelled by an external force. So when an external force is applied, you can change the property of inertia of objects. So Newton's first law states that to change the property of inertia of bodies, we need to apply an external force. So Newton's first law gave the first time the definition of force. Then Newton's second law explains how can you measure the force. Now coming to consider two bodies which are having different masses. Suppose body A is having mass m1 and body B is having m2. That means both the masses are different. So let mass A is greater than mass of the body B. Then when these two are moving, to stop ball A and B, which will be needed more force? A will be needed greater force. So force is directly, from this you can say force is directly proportional to mass of the body. Next, suppose if both the bodies are having same mass, let it be the mass will be of these two bodies, let the two bodies mass may be m only. Then but they are moving with different velocities. Let the velocity of body A is v1 and B is v2. Suppose when these two are moving, to stop this body A requires more force again, since v1 is greater than, since v1 is greater than v2, we need more force to stop ball A. From this example, we can know that force is directly proportional to velocity of bodies. So now, what is momentum? Momentum is designated by T. Now, according to the physics, momentum is nothing but the quantity of motion possessed by a body. Mathematically, momentum is the product of mass and velocity. So P is equals to m into v, where since v is a vector quantity, P is also a vector quantity. So what is actually momentum? By definition, according to physics, it is the quantity of motion possessed by a moving object. quantity of motion possessed by a moving object is known as momentum. And mathematically, momentum is nothing but the product of mass and velocity. Now coming to the definition, the units of momentum. See, mass is SI unit of m is kg and velocity is meters per second. So momentum is equals to meter per second, kg meter per second or kg meter seconds inverse. So again, suppose 1 kg of mass, that means 1 unit mass of a body requires 1 unit of velocity. So the quantity of motion possessed by this body is 1 unit, that is 1 kg meter per seconds inverse. Since here velocity of the body is a vector quantity, momentum also is a vector quantity. So mathematically, what is momentum? Momentum is the product of mass and velocity. Now once again we will be seeing, suppose let us consider two bodies of different masses A and B. A is possessing a mass of m1, B is possessing mass m2. m1 is greater than m2. Then if those two bodies are moving, we require more force to stop the body A. That means when mass is greater, external force applied to stop it also will become more. So F is directly proportional to m. Suppose these both are having same mass m, but they are moving with different velocities, that is v1 body A is moving with v1 and body B will be moving with v2, where v1 is greater than v2. Then to stop this balls when moving with different velocities, the fast moving ball is A, it requires more force to stop. So by this example we will come to know that force is also directly proportional to velocity of a moving body, which is known as the quantity of motion. What is quantity of motion? Is nothing but momentum of a moving body. So this mathematically, momentum of a body is nothing but the product of mass and velocity. Since velocity is a vector quantity, momentum is also a vector quantity. Now coming to the units of momentum, mass is, according to SI unit, mass is kg and velocity is measured in meter per second. So momentum is nothing but kg meter per second or kg meter inverse. Now coming to Newton's second law of motion. Newton's second law of motion states that rate of change of momentum of a body is directly proportional to the applied force and acts in the direction of force. Now, what is rate of change of momentum? Now, suppose a body is moving m with mass m. Suppose this body is having mass m with a force F. Your applied force is F. Time is 0. Then the initial velocity of this is u. When at time t is 0, its initial velocity is u, its mass is m. Now when you are applying the force, suppose it is moving with the applied force a little distance, that is, it moved. Now this is the body displaced till here. So the force is F and T is equals to T. Then this, now the velocity is, let it be V. Now suppose initial momentum of a body, let it be V1, is equals to, already we discussed and defined what is momentum. Momentum is the product of mass and velocity. Suppose its initial momentum is mu and final momentum is P2 is equals to mv. Now what is change in momentum? Change in momentum is final momentum minus initial momentum. Minus initial momentum. Now change in momentum is fine, that is P2 minus P1. Now you can take it m as common. When you take m as common, m is equal into v minus u. Now already we discussed that rate is nothing but time. Now rate of change in momentum is directly proportional to the applied force, we told, and acts in the direction of applied force. This is the definition of Newton's second law of motion. The applied force and acts in the direction of the force. Now what is change in rate of change in momentum then? Rate of change in momentum is equals to m v minus u by t. Rate represent t. Now from first chapter you know that, what do you know? V minus u by t is equals to, this part is equals to a. So rate of change of momentum. Now you can write rate of change in momentum is equals to m v minus u by t, we are saying. Since m v minus u by t is equals to a. Now what is rate of change of momentum? Directly proportional to f. So f is directly proportional to m v minus u by t. That is from equations of motion. First equation of motion, v minus u by t is equals to a. Substitute, since this part of the equation, since it is equals to a, substitute f is directly proportional to m a. A is what? Acceleration. A is acceleration. Since a is vector quantity, force is also a vector quantity. Now you need to remove this in proportionality constant. So f is equals to k ma. This is the derivation for Newton's second law of motion. So what is Newton's second law of motion? Is nothing but when an external force is applied on a body, the rate of change in momentum of a body is directly proportional to the external force applied and acts in the direction of force. So we have derived, considered one body with mass m and its initial velocity at time t 0 seconds is u, and when you are applying external force, it moved and its velocity changes to v and time from 0 to t. So let us deduce the formula now. With initial momentum, is equals to mu, since momentum is the product of mass and velocity. So initial momentum is equals to mu and final momentum is equals to mv. Change in momentum is equals to final momentum minus initial momentum, that is mv minus mu. Then taking common as mass, you will get mv minus u. Now by definition, what is rate of change of momentum is directly proportional to the external force applied. Now rate of change in momentum, rate represents the time. So rate of change in momentum is equals to mv minus u by t. Now by definition, this is directly proportional to f. So f is directly proportional to mv minus u by t. From the first lesson already, equation of motion, you know that first equation, v is equals to u plus at, a is equals to v minus u by t. So substituting this a in this formula, f is directly proportional to ma. To remove this proportionality constant, we will be using k. So f is equals to kma. So k here represents the proportionality constant. Now, so that is equals to f is equals to ma. This is Newton's second law of motion. Now this gives the derivation of, so mathematical derivation and measurement of motion. What it is giving? Newton's second law of motion gives measurement of force. Now coming to the units of force, since mass is SI unit is kg and acceleration is meter per second square, so force is equals to kg meter per second square, that is kg meter seconds inverse square, seconds inverse square, kg meter seconds inverse square. This is the SI unit, and in order to honor Newton, they have given force, SI unit of force is in respect to Newton, SI unit of force is equals to Newton. Now 1 Newton is equals to 1 kg meter per second square. What do you mean by this? When a body of mass 1 kg produces an acceleration of 1 meter per second square, when an external force is applied on it and acts this acceleration in the force applied direction, then the force applied is said to be 1 Newton. In other words, when 1 Newton of force is applied on a body of 1 kg mass, it produces an acceleration of 1 meter per second square. See, all 1, 1, 1, that means unit. 1 unit mass. On 1 unit mass of a body, if you applied 1 unit of force, external force, it produces an acceleration, 1 unit of acceleration in it. Then it is said to be 1 Newton. So 1 Newton of force is applied on a mass of 1 kg of object. It produces an acceleration of 1 meter per second square, which is known as Newton. This is the definition of SI unit of force.